This video is Binomial Distributions Part 4. We're picking up with the Whataburger contest question. We've looked at this question earlier, or the scenario. Whataburger is running a contest. If you buy a burger, it comes with a pull-off tab. 25% of the tabs say you win a free small fry, while the remaining tabs say better luck next time. If you buy a burger, your chances of winning is 0.25. However, what if you decide to buy burgers for 10 of your friends? We want to find the probability that exactly 3 of them will win a free small fry, the probability that half of them will win a small fry, and the probability that all of them will win a small fry. And so, if you will recall, we talked about how to do this with the calculator. So if you want the probability I'm having trouble with my pen here. The probability of 3, exactly 3, that is the binom PDF function in the calculator. And remember, for binom PDF, we need 3 things. We need N, P, and X. And for some of us, the calculator will prompt that. For others, they need to be able to type it out in this order. So what is the number of trials? Well, how many hamburgers are we buying? We are buying 10 hamburgers. So that's the number of trials. N equals 10. Next we need P. What does P equal? P is the probability that we will win a hamburger if we buy just 1 hamburger. So that is 0.25. So 0.25 goes next. And then X. That's the probability, that's the random variable. The number of successes we're trying to find the probability of. So we want to know the probability that we'll win exactly 3 small fry. So 3 goes there. X equals 3. Now, all we have to do now is pull up the calculator and calculate what that probability would be. By the way, this is how you would show your work. You would write out the function in the calculator along with the numbers you would put in. Oops, go back. Okay, so to do this, we're going to choose Binom PDF by going to second bars, Binom PDF, and the number of trials this time is 10 for buying 10 hamburgers. The probability of a success is 0.25, which is not bad, and the X value is 3, and we get 0.2503 when we round to 3 decimal places. 0.2503. Alright, so next, what is the probability that half of them will win a small fry? Well, how many is half? Half of 10 would be 5. So we want Binom PDF. Oops, I forgot the D. PDF. And our N is still 10. Our P is still 0.25. And our X is 5. So that's what we're going to put here. 10.25. 3. Sorry, that last number should be 5 because we're doing half. And if you do second vars and you put in 10.25 and 5, you should get 0.5. I'm sorry, 0.0584. So basically, that's about a little over 5% chance that 5 people would win the small fry. So we don't have a lot of space for this one, but look what it says. What's the probability that all of them will win a small fry? Let's just go to the white screen. So probability that all 10 will win a small fry. So that's exactly 10. So we will use the Binomial PDF function, and the number of trials is still 10. The probability of a success is still 0.25, and X in this case is all of them. All the hamburgers would be 10. So we're trying to see if all the hamburgers would have winning tickets that say free small fry. So we're going to type in second vars, Binomial PDF, 10.25 and 10, and we will get 9.5367. It keeps going, but I rounded to 4, e to the negative 7. Now here's the deal. This number here, that number is bigger than 1, and if you'll remember, probabilities have to be between 0 and 1. Alright, so that is definitely not between 0 and 1. Actually, it is because of this e to the negative 7. So this is scientific notation. This stands for 9.5367 times 10 carried to the negative 7th power. And basically, to do this, now you don't have to rewrite it like I did just there, but basically what you do need to do is you need to rewrite this in regular format, not in scientific notation format. So what you're going to do, I'm going to write the number right over here, 9.5367. I'm having a time with these extra lines that keep popping up. Okay, so what you're going to do is you're going to move your decimal, this right here, 7 places in the negative direction, which is to the left. So 1, 2, 3, 4, 5, 6, 7, and that's where your new decimal is going to go. Now, everywhere there was not a number, you're going to fill it in with a 0. So your number ends up being 0.000000953667. If you count, you have a decimal followed by 1, 2, 3, 4, 5, 6 zeros. Now, we also can't leave it like this. We need to round it to 4 decimal places. And that 0 tells this 0 to stay a 0. So our answer rounded to 4 decimal places would be 0. Sometimes with probability you get a probability really small, like this one, and it's very, very small. It's not exactly 0, but it's pretty close to 0. So a lot of times what people do is they add a little plus sign so that you know it's slightly above 0, but not by much. You don't have to do that, but I just wanted to alert you just in case you did ever see a 0 plus. That's what it means. It means that it's really, really close to 0. That when you round to, say, 4 decimal places, it rounds to 0. Okay. So this last one we just did. Alright, now this slide is a review of what I did in the last video where I showed you how to find all the probabilities at once using the lists in the calculator. So just to review, in L1 we put all our x's. So for the Whataburger problem, you're going to put the numbers 0 through 10 in into L1 because you can have anywhere from 0 successes to 10 successes. Because if you're buying 10 hamburgers and 25% of the hamburgers have a tab on it, a pull tab that has a you win a free small fry coupon, and we bought 10 hamburgers, then there's a possibility that none of the hamburgers have that, or 1 has that, or 2 has it, or 3 has it, so on and so forth. Now in L2, we highlight L2, so make sure you arrow up all the way to the top of L2 so that L2 has a black box around it. And you're going to type in the formula, which is Binomial PDF. Second vars, choose Binomial PDF, put in your number of trials, which is 10, comma, or fill in the prompts, the probability of a success, which is 0.25, comma, and here's where it gets different, because you want this to populate the probabilities for all of these random variables occurring, or all of these successes. You're going to need to put where those are located, and they are located in L1, and it will substitute each one of these numbers into this formula at the bottom and then populate the L2 with all the answers. So let's do this for the Whataburger experiment. Alright, we're going to go to Stat, enter, clear out our lists. I'm going to type in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And hopefully all of those numbers typed. I'm going to check real quick. Don't forget to always start with 0 because you can always have 0 successes. And then I'm highlighting L2, making sure the black box is around 2, and I'm going to hit second vars. I'm going to choose Binomial PDF. I'm putting in 10.25 and L1. Paste, hit enter, and here we go. We have all of the probabilities right here. So I'm going to go to the next slide, but I'm not gonna make the screen big yet. I'm going to defer to this calculator because it's going to help us. Now, repeating this Whataburger question, after we've calculated the probabilities, which we have here, if you scroll down, you can see we have all the probabilities all the way to 10. Some of them are in scientific notation, in which case we would have to move the decimal over to the left. Okay, so what is the probability that less than 3 of them will win a small fry? What's the probability that less than 3 of them will win a small fry? So how many successes would be less than 3? Less than 3 would be 0, 1, or 2. So what you have to do is you have to add the probability of 0, 1, and 2 together. Okay, so the probability that it's less than 3 is the same as the probability of 0 or 1 or 2, because those are the numbers that are less than 3. So if you look at your calculator, I had to close mine out so I could write on the screen. The probability of 0 is 0.0563. I'm going to add that to the probability of 1, which is 0.1877, and the probability of 2 is 0.2816, and we get 0.5256. So why don't you try the rest of these? Pause the video, and when you unpause, I will have the answers up. So here we go. Probability of greater than 7, add probabilities of 8, 9, and 10 together, you get 0.0004. For no more than 4, that's 0, 1, 2, 3, and includes 4, you get 0.9219, and the probability of at least 8 is 0.0004.